guys, welcome back to my channel Programming with Pirai. In this video, we are going to see about Leetcode question number 90, subsets 2. If you don't watch my subset 1 video, that is the previous video in this playlist, just go and watch it. I will give the link in the description, then continue this video. Because that recursion is completely used in this recursion, but we do a slight optimization. Or we can do a slight variation, that's it. Okay. Now, see here, given an integer array nums that may contain duplicates, return all possible subsets. Okay, the solution must not contain duplicate subsets and also return in any order. The question is wrong. See here, any order. They are asking us to find in any order, but when we are submitting in any order, it be shows wrong. Okay, it is like a sorted order. We want to return the solution in a sorted order. That's what the question means. Okay, here the question is wrong. So it is right. We want to return a unique subsets. That's right. Okay. Now let us see this example. See here, 1 to 2. For 1 to 2, if I draw the recursion tree, it is like this, right? So this is my recursion tree, right? You know this because we in the previous itself we have seen about this recursion tree, right? In previous video itself, in subset 1 video. Again, I'm telling you, if you haven't seen the subset video, just go and watch it. Now you can know about this backtracking approach. Okay. Now see here, what are the subsets I can get if I do this method 1 to 2, again repeating this 2, right? Here see, 1 2 is again repeating. So I can say from this, if I do the ordinary subsets problem like that for this approach, I will end up with getting a duplicate values, a duplicate subsets, right? So how can we extract the unique values from this? I can easily say that just put into a set data set. If I put into a set data set, this all will be the unique values, right? So just written it. I can tell you like that, right? So what are the steps involved? First of all, you want to sort the array. Sort the array. You may ask why we are sorting the array, because the question is wrong. The question is wrong. It is not in any order. We want to return in only the sorted order. I will show the test case also. Okay. Now the second one is we want to find all subsets, all possible subsets. Then we want to push them into a set data set. Then we want to return the result. So these are the 3 steps involved in this first approach. Okay. What's the brute force approach? Time constraint and space constraint. I can say my time constraint will be O 2 power n for generating all subsets. Then n for just pushing the length of n subsets into what? Into a set data set. Because pushing a subset of length 1, 2, 2, which length is 3, will not be the constant. It also takes a time. That's the n. Okay. Into log of 2 power n. You may ask why log of 2 power n? Because just inserting inside a set takes a log n time constant. So it will be maybe a 2 power n when all are unique. So it will be log of 2 power n. And what is the space constant? It is 2 power n. You may ask in previous approach. That means in subset 1 problem, it is only n because of the stack size. But here, why it is 2 power n? Why the space constant is 2 power n? You may ask. Just observe carefully. There we used what? Resultant array. Resultant array will not be taken part in the space constant. But here we are taking what? Set. Set is what? Auxiliary space. So that should be taken as a space. Okay. That should be taken in the space complexity also. So my time and space complexity will be like this. Can we optimize it? Okay. Further, if I want to optimize it, what are the changes I need to do? I can reduce this space complexity as the original subset problem itself. Like I can reduce this as O of n. Yes. And I can reduce the time complexity as what? O of n into 2 power n. I may reduce like this. Okay. So can we reduce this subset problem 2's time complexity to a subset problem 1? Okay. To convert into this, what we should prevent of taking this set data set. If we don't take this set data set, we can absolutely get this result, right? We can absolutely get this result. Okay. How we can do this? Let us see. Let us analyze this recursion tree. See here. This 1 2 is repeated here also, right? Here also. Why it is repeating? If you understand this detailedly, you can say this answer. Why it is repeating? See here. Here we are taking what? First in this. Here we are taking what? Second in this. And this first in this and second in this values are what? Same. So by this itself, you can say if a number or an element is taken already, then that same element cannot be taken again. from different indices also. We cannot take this first index 2 times, but we can take this first index and this second index 1 time each, but the values are same, right? So this is the contradiction we have. So we don't have to take the same value twice in the same level. You may understand once again. See here, this should be eliminated, right? So if I don't take this 2, the second index, this will be eliminated. Okay, come here. Here also 2, here also 2. So I can say if I don't take the first index, if I don't take the second index again, it will be reduced, right? The recursion call will be reduced. So we cannot take this. So I can say in each level we only take the unique values. Can you understand? In each and every levels we want to take the unique values alone. So that's the only one thing we can do, such that we only end up in unique subsets. So what I'm trying to say is, first step, we want to sort the elements, right? Because in any order they are asking the question, but in real time it is a sorted order only. The question is wrong. So we want to sort the array. And the second step is, we want to just check whether it is a duplicate. If it is duplicate, we cannot go for the recursion. If it is unique, then we can go for the recursion. It is simple, right? If I have an array like 1, 2, 3, 3, 4, 4, 4, in one level I can take this 1 or this 2 or this 3. I cannot take this 3, and or this 4. I cannot this 4. This 4 also not be taken. Can you understand this? Yes. So you want to take the unique values in every levels. And the third thing is, we want to insert into a result. That's it. So these are the 3 steps we want to involve, right? Okay. Let us see the code now, so that it's more clear. See here, this is a code. Result is equal to set of. Now the combination of index comma auxiliary comma nums, and then result dot add of tuple of auxiliary. So in Python, we cannot directly insert that list into the set data set. We want to convert into a tuple, then we can insert it. Okay. Now for I in range of index comma len of nums, and these are all same as the previous subset 1 problem itself. In previous video also I written the same recursion call, right? And here that's a change. What is the change? We want to sort it first. Let me submit it. Yes, it is submitted successfully. Just take for example, if I don't put this, now let me submit it. I'll get an error. See here. Yes. What is the error? These elements are same as my element also. The expected output is same as the output that I have given. But see here, the order is changed, right? So the question is wrong. The question should be what? It should be a sorted order also. In discussion also they have given like that. The question is wrong. Okay. So we want to do this. Fine. Now let us see the second code. Now see the second code. It is what? Result is equal to empty list. Now the combination of index comma auxiliary comma nums. Okay. Now I am just taking a copy of that auxiliary inside my result. I will tell you why I am taking the copy. Now here it is same. For loop is same, but only one condition is added. What is the condition? If I is not equal to the index, which means just take for example, if index is equal to maybe first I will take an array like this 0, 1, 2. Let me take index value is something like 1. Then I can take this 1. I cannot take this 2, right? I cannot take this 2. So I want to check whether in for loop we can only take what? This 1 and 2. In for loop we can iterate for this 1 and 2. And I can take this 1 only in that level. I cannot take this 2, right? So I'm trying to, I want to check whether index is not equal to I. Yes, for this 2, index is not equal to I, because 1 is not equal to 2. And also 2 is equal to 2, right? The previous element and the current element is same. So I can say that I don't want to go for that recursion call. That's why I included that condition here. Now hope you understand this, right? Now the same recursion call I have done here. Then while passing into the function, before that result, we want to sort the array first. Then we want to pass into the function. Then we want to return the result. That's it. Let me submit it. Yes, it is submitted fully. Now, the importance of this copy of method is, if I don't give this copy of, then let me run it. I will get the all empty list. Why? Because why we are getting this all empty list? Because see here, at last, while backtracking, I will get what? I will get the empty list here. I will get the empty list here, right? So in Python, if I don't copy it and I initialize to the initializer, like take for example, there's a list. If I initialize this list to A and I do some modifications on this A, then this original list will be modified, right? That's how it is converted to what? Again, to an empty list. So we want to do what? A copy of. Can you understand this? Okay. Now it's time to see the time constant space complexity for this solution. Okay. Tell me about the time constant space complexity. I can say my time complexity will be 2 power n to generate all subsets and n for inserting the each and every subset into a resultant array. That's not a constant time, right? Now space complexity is O of n. So this same as the subset 1 problems. Time complexity and space complexity. Now just observe this. Why it is O of n? It is same as the subset 1. See here, first of all, this is our recursion stack will contain this function. So it will be length of 1, then 2, then 3, then 4. Then it will be killed, like it will be popped out, then it backtracks, then it will be popped out, it backtracks, then the length will be 3. Like that only we have done in the subset 1 also. In subset 2 also it is same. In subset 2 also it is same. Now hope you understand why this time and space complexity is obtained. Thank you.